Alright, let's look at questions 41 to 43. These three questions deal with a regression that has as its only independent variable a dummy variable di. About the regression, what we are looking at is the impact on wages in the labor market, or the impact on wages of what gender you are. So here we are using a dummy variable to represent the gender of the people who were surveyed, and we assign the value 1 to the dummy variable if the person is male and 0 if they are female. The sample has a size of 200, of which 150 are males and 50 are females. So there's 150 ones here and 50 zeros, right? So this means that apart from random errors, on average, males get 300 minus 50, which is they get an average wage of 300 minus 50 or 250, and females get 300 because DI is 0, right? So we have this equation which looks at the impact of gender on wages. Now, the first question, question 41, asks you it's a very straightforward question. It asks you simply what the average wage in the whole sample is. Well, the average wage, taking average over this, average of a constant is the constant, average of a constant times a variable is the constant times the average of the variable, and since we are doing an OLS regression, the average of the error terms that we observe is assumed, you have an intercept term, so that comes out to be 0. So since UI bar is 0 and DI bar is, there are 150 ones and 50 zeros, so the DI bar is 3 by 4. So you get 300 minus 50 into 3 by 4, which is 262.5 is the average wage that you get. So that's for question 41. Moving on to 42. Alright, let's put that aside for the moment. Let's finish 43 and we'll come back to 42 because that's a normative question. 43, the idea is that, again, very straightforward. It just asks you what the estimated sum of squares in this regression is. The estimated sum of squares is the sum of the squares of the deviation of the part of the dependent variable, in this case the wages, that is explained by the regression, which is to say that the part that is not a random error, which is to say 300 minus 50 di, so which is simply the wi, which is the dependent variable, minus the error term ui. So you have the sum of the squares of wi minus ui minus its average. Now this average, since ui bar is 0 and wi bar is 262.5, this average is simply wi minus ui, which is 300 minus 50 di minus 262.5 the whole square. Now if you work this out, this will come out to be 93,750. Yeah, 93,750. So again, pretty straightforward. You just plug the stuff in and it just pops right out. Going back to question 42. So this question deals with the concepts of what it means for a regression that you run and the coefficients that you get out of it. What does it mean to say that the regression is precise and to say that the regression is accurate? Well, whenever you run a regression, there are essentially, alright, so in this particular case, what you're really interested in is the effect of di on wi, which is given by this coefficient 50 here. Now, note that there are two numbers here. There is the coefficient, which is 50, and there is the standard error of the measurement of that coefficient, which is 10. Now, note that a standard error of 10 for a coefficient of 50, that's pretty big, right? It looks pretty big. Now, the idea here is simple. Precision, accuracy means that this number 50 that you get is actually pretty close to what you get from the sample is actually pretty close to what it is for the population as a large. So accurate means that the number that you're getting is about correct. there aren't any large biases or inconsistencies, it's accurate. Precision, on the other hand, simply means that, well, each time you draw a sample, do a measurement, work out the average, you might get something slightly different. Each time it will be slightly different. You pick them all up together and you have a distribution of coefficients each time you do this exercise, hypothetically speaking. Precision means that the standard deviation of this distribution of coefficients is small. The more precise your estimate, the smaller the standard deviation. What does that mean? That means this standard error is small. Now, accuracy in a particular estimation depends a lot on, letting things balance out. I mean, if you are doing a regression to study the effect of a variable x on a variable y, the idea is that you want a sample that is pretty representative of your population. So in this particular case, since you're using a dummy variable and there are males and there are females, now your population will have a certain ratio of males and females. You want that your sample reflects that same proportion. And if that happens, which is probably not the case here, if that happens, then the coefficient that you get out of this will be a pretty good estimate of what the effect of gender on wages really are, which means that it will be accurate. So the sample composition, in particular, whether there are equal males or females, or whether the males and females are in the same proportion as they are in the population, that determines whether your beta will be accurate. Precision, on the other hand, does not depend on sample composition at all. All that matters to get a precise estimate is that you have enough numbers of both males and females. In particular, well, for your statistical test of the significance of the coefficient to be valid, you would need at least 30 of each type, male or female. So yeah, in this particular case, precision does not depend on the sample composition of men and women. It only depends on the fact that you have enough of both.